Hi guys, and welcome back. Mr. G here. This is episode 2 of our journey to discovering compound identities. So in the previous episode, we proved this fact here that cos A minus B is cos A cos B plus sine A sine B. We have proven it is a fact. We can now use it. So the first or the second identity rather that we are going to have a look at, or we're going to try and figure out, is cos A plus B. I know I used alpha and beta in the previous one. So really, I'm going to try and use different variables now and then so that you guys do not become stereotyped a bit. You can be quite flexible and know that any symbol can really be used to denote this stuff. So what I'm going to do here, I'm going to be sneaky. So here's a life principle. If you're not strong, you got to be smart. Okay, that's how David killed Goliath. So now we're going to go cos A minus B. You see that? Yep. Now we apply the formula. This should be cos A, cos of minus B. I should have a plus there, sine A, and sine of minus B. Okay, then this is cos A. We did negative angles, and this is exactly why they come in handy now. Now, a negative angle for sine will just be that, and they usually say sine is an odd function and cos is an even function. So hence that thing. But of course, we've used the Cartesian plane to prove the negative angles. So that's it. We are done. End of proof. Let me quickly get into the second one. So what about sine A plus B? Oh, what is that? Well, guys, we're going to be sneaky again here. Yeah, that's one thing about math. Manipulation. Yeah, mathematicians are actually very good at that. Yes, it's an art. We know sine A. Let me not use A because we've got it here. So we know sine theta, when we did cofunctions, is actually cos 90 minus theta. So I'm going to use that here. It's true, it's a fact. We've looked at it in the Cartesian plane, so why not? So I'm going to go ahead and write this thing as cos 90. Now, what is my theta? My theta is A plus B in this case, okay? So I got to be very careful there. I'd say this is a crucial step in proving this identity. Now, I'm going to simplify a little bit whatever is inside the brackets here so that you can be with me now. This is what I have, okay? Now, I can go ahead and be sneaky and do that. Whew, how cool is that? So, when I've done this, I'm actually now done because I'm going to apply the formula right away. So I know I need a cos 90 minus A here, cos B, and then I must have what? Plus, okay, sine, I get what? 90 minus A, and then sine what? Sine B. I'm applying that identity up there. Now, cos 90 minus A, that's a co-function. So this must reduce to A, and I have cos B there, and I have plus, but it's sine 90 minus A, that must reduce to cos A, and I have sine B. That easy? Yes, I promise you it is that easy. Guys, I'm going to allow you to try and prove the last identity, or at least figure out what sign A alpha minus beta is, okay? Please try that. It should be quite easy. As a matter of fact, I'll say to you, you can now choose between using this identity here and this identity here that we have just discovered. So you've got three identities at your disposal. So just don't confuse yourself. Choose the easiest one for yourself, okay? So either you can say, you can use this, okay? Choose between A minus B So because I said alpha again, I'm going to use, in the problem I said alpha. So as a hint, you see, I'm being nice. I'm nice. So I'm gonna say choose between alpha. I mean this formula here. We know it. We just proved it. This is cos A, cos B minus sine. Why now am I using A and B's again? So that is a beta. That is an alpha. I am really sorry for that mess. It's disgusting, huh? Let me get rid of it. Yeah, sorry for that mess. Cos alpha, cos beta, my pen is quite slippery. Then, or you can use sine alpha plus beta, which we now know it is sine alpha cos beta plus cos alpha sine beta. Or finally, the original Magoya that we have proved, uh, alpha minus beta is cos alpha cos beta, could I have a plus there, sine alpha, sine beta. So go ahead and put yourself to the test and see if you can if you can do this. Oh yeah, if you can do this. I'm sure you can. I believe in you guys. Um, you need three things at least for mathematics. Let me just share this with you. You need to have some patience, be patient with yourself, have the correct attitude, and be resilient. Have some sort of resilience. Make sure that when you struggle a little bit, you don't really give up. Maybe take a 2-minute break, go back to that problem, and see if you can kill it. So please, all that you need is time. You need patience, and you need some resilience. Okay, that is a mathematician there. Yeah. All right, guys, we'll end it here, and I'll see you in the next discussion where we're now going to derive the double angle identities. Cheers.